Good afternoon, everyone. All right, I'm recording the class, okay? I did it, and let me see. Okay, with this. Yep, today's our last section, okay? Yeah. Okay, now we're gonna finish this one, geometry, which is a Pythagorean theorem, okay? Maybe you can see the graph, the figure up here. Everyone knows this one, okay, but what is the Pythagorean theorem? Yeah, I believe that. Okay, when you have a right triangle, this is a right angle. Now, this triangle is called a right triangle. Can you see that over here? Right triangle. Right triangle have two legs. This side you said leg, another leg over here. Because when you have right stand over here, okay? This is your leg, but they are perpendicular. Okay, this is the leg, another leg. But in this case, it doesn't have to be the same length. Okay, that's the difference of our human being leg. This is the leg, another leg. This side is called hypotenuse. Okay. Okay, on this right triangle, there are very interesting property. Okay, there are interesting property. Okay, first of all, I want to make just a simple square. I'm going to use the square. Okay, this is not square. Okay, I'm going to use, okay, the paper. This is a right triangle. We have two legs and one hypotenuse. I'm going to use this one, make a square. This side is A, the other side is B, another square over here. Now this side is C, another square over here. What is the area of this squared? A times A, because the square is what? Both the lengths are equal, right? So A times A is what? A squared is the area of these squares. Second one is this is B, this is also B. What's the area of this squares? B squared, right? B times B squared. What is the area of this another square, which has a hypotenuse C? This is C, that is C squared, right? But between these three areas, there are very interesting property there. Sum of these two areas, A squared plus B squared, exactly equals to this area, C squared. So this is called Pythagorean theorem. I just used what at each side, I used a square. But I'm going to extend this one a little different way. It doesn't have to be square always. It doesn't have to be square always. Any similar is okay too. I'm going to do semicircle. This is semicircle. This is a semicircle. If this side is, I'm going to use A area, but this semicircle is A. This semicircle area is B. This semicircle area is just C. Still, what is that? Sum of these two areas equals to the other area. This is also Pythagorean theorem. But on your grade, we use only square, right? But remember, Pythagorean theorem, it doesn't have to be always squared. Anyway, sum of these two areas equal the other one. It can be semicircle or similar, right? Another one, any similars, you can attach any similars. You can attach any similars. I'm going to attach over here, equilateral triangle. This is equilateral triangle. This is another equilateral triangle, another equilateral triangle. So if this area is A, this area is B, this is right angle, this area is still A plus B equals to C. That's a Pythagorean theorem. Okay? Now, especially we're gonna focus on square side because we can see A squared plus B squared plus C squared on this figure, right? Why this is true? Maybe, okay, before we get in our classwork, maybe there might be help to prove this one. Okay, let's prove this one. Why A squared plus B squared equals C squared? We can prove this one. Okay, let's just one times prove, okay? There are, I think, more than 120 different ways. There are a lot. You can check right internet, so many different ways. Easier way, difficult way, and high technology and high advanced way, a lot. But on your grade, I'm going to use what very, very easiest one. What is the easiest one? This is a square. This is a square. Inside, I'm going to make another square, okay? But not in the middle, a little different way. Because we use why A and B doesn't have to be equal. So A squared plus B squared equals C squared, okay? I'm not gonna use why A equals B, okay? A and the B is different. This is A, B is different over here. This is A, this is B. This is B, okay? And this is A, this is B. So that's a square. This way. Okay, but inside is still square. But this side is just C, isn't it? All right, what is the area of this square? C squared, everyone understand, okay? This area inside the square is C squared. What is the area of this side? What's the area? 8 times B and divided by 2, right? This side is what? 8 times leg times B and divided by 2 is this area. Okay, it's the same area. How many of this one? 1. This also what? AB over 2. This area also A times B over 2. This one also A times B over 2. Okay, this one a little hard because you guys don't learn factory. Okay, okay. Now this side is how much accurate? This is A plus B, right? This side is what? Also A plus B. What is the area of this large square in terms of A and B? A times B times A times B, A plus B, right? That's the area of a large squares. Now let's simplify. A times A is what? A squared. A times B is what? AB. B times A is still AB. B times B is what? B squared. Okay, we just find what area of this large square. Now I'm going to express what the area, same area using what? This one, this one. This is the area of large, not same area. I'm going to find different way. C square first. Same area is what? C square and plus this area is what? AB over 2, right? AB over 2. But we have how many of this one? 1, 2, 3, 4 times 4. Okay, we just find what the area of same square, okay, in 2 different ways. Here one and second one. but they might have the same number, right? Same squares. That is equal to, I'm going to write down. Okay, I'm going to write down one more here. A squared plus AB times AB is what? 2AB and plus B squared. That is equal to this area, right? This area over, move over here. C squared plus AB over 2 times 4. This is 1, this is 2 still. 2AB over here. Can you see the same number? Yeah, 2AB, same number. Minus 2AB minus 2AB is going to be 0. This is 0 out. Now find what is the A squared and B squared in your left hand side. Right hand side is C squared. This is, we said, Pythagorean theorem. This is very interesting, right? All right. Maybe you can see another method on the internet. Okay, there are a lot. Okay, but this is the easiest one, but you don't have to go right hard one. But if you are interested in the Pythagorean theorem, you can take a look. Okay. All right. Now we have 2 legs because the right triangle, you must memorize, okay? The name of the right side, okay? This side, not hypotenuse, okay? Adjacent of a right angle is called legs. Now, hypotenuse is what? Longest side is hypotenuse, which is what? Opposite of right angles. Opposite side of a right angle, okay? That side is called hypotenuse, okay? All right. Okay, you can use, okay, the measure. I'm not going to use this word measure, okay? Because we already know that A squared plus B squared should be C squared. We know that, we proved already. If you use your ruler, exactly what it works. So C equals what is the square root? We did already, right? Square root, that's why we learned. Square root is what is that? A squared plus B squared, isn't it? All right, A is the leg, B is the leg, C is what? Hypotenuse, okay? All right, you can see it over here. The relationship between the sum of the squares of legs and the square of hypotenuse for every right triangle, that is always equal, okay? You can see that A squared plus B squared is C squared, or leg 1 squared, because they said this is the leg 1, the other leg 2, okay? They're always equal. For examples over here. We have a right triangle has leg with side is 5 and 12. Use the Pythagorean theorem to find the length of its hypotenuse. Okay, on hypotenuse you can use what C or X. You know that 12 square, leg square, and plus another leg 2 square is 5 squared. That is equals to what? Hypotenuse squared. That is equals to X squared. All right, now we need to find the value of X. 12 squared is 144. I want to memorize all this, okay? 5 squared is 25. Total rate how much? 169. 169, that is equals to what? X squared. When you multiply the same number 2 times, that is 169. What is X? Square root X, square root X. X equals how much? 13 times 13 is what? Square root 3069, okay? So which is 13 is the answer. So this side is what will be 13. Everybody got understand? All right. Now the next one. So remember, when you have 5, 12, hypotenuse will be 13. Memorize this one. This number is called what? Right triangle. triplet. Okay? If you got these numbers at their side, you can say, oh, this is the right triangle. Another one is what? 3 to the 4 to the 5, also right triangle, triplet. Another one is what? 8 and 12 and 17, also right triangle, triplet. Memorize all these three numbers. Because we know that from here, 3 square plus 4 square is equals to 5 square, right? That is true. 9 plus 16 equals 25. What about over here? 8 square plus 12 square equals 17 square. That is true. 8 square is 64. 12 square is 144. I did wrong. 15. 8, 15, 17, right triangle triplet. Okay, I'm sorry. 8 square and 15 square is equals to 17 square. 8 square is 64, 15 square is 225, 17 square is how much? 289. Is it true? Okay, so 8, 15, 17 is the right triangle triplet. Okay. All right, sometimes the length of side is irrational, but it's okay. It doesn't have to be already a rational number. But in this case, when this is x, you're gonna find the length of this side by Pythagorean theorem. 12 squared plus 9 squared should be equals x squared. 12 squared is 144. 9 squared is 81. Total is how much? 225. 225 equals x squared. What is the value of x? When you multiply same number twice. X equals 15, isn't it? You can use a square root. Square root. That is x equals, you can see that we are 225 is about 15 times 15, right? Two equal number over here. That is about red 15 times red 15 is about just 15 by definition, right? X equals 15. That is okay? All right. But sometimes it doesn't have to be irrational. It looks like this one. This is x over here. Okay. Now I'm going to write the x squared first. X squared equals what? 10 square leg square plus another leg, 8 square, right? That's okay. 10 square is 100. 8 square is 64. But this is not perfect square numbers. 164 is not a perfect square numbers. Square root. This is the square root x squared, this is x equals. Now we got this one, square root 164. It's okay? Right. And also, okay, square root problem, we learned, the last time we didn't do that. Okay. Anyway, if you have, okay, for example, if we have right square root 12, for example, but we know that if we have two numbers equal inside, this looks like this one, square root 2 times square root, the same number. It's going to be 2 in it by definition. That means, well, if we have perfect square numbers inside the radical, it should be simplified. That is not anymore irrational. 12 is what is that? 2 times 3. These two numbers is what equal. Square root 2 times square root is 2, right? So that is actually kind of a move to the out. So what is that? 2 a radical 3 is the simplest form. The idea is what? Inside the radical, perfect square numbers, perfect squares cannot stay there. must move out. That is okay. Now we got over here, square root 164. Square root 164. Now let's find the perfect square number. Oh, you can divide it by 5. 41. Yes, this is the perfect square number. 2 times 2. 41 is a prime number. That's all. So I'm going to write that one more time. This is what 4 is what 2 times 41. This is perfect square numbers in there. It's going to move out 2, right? Red 2 times red 2 is 2 by definition. So 2 red 41 is just simple stuff. It's okay. So this one is actually 2 red 41. That's fine. This side actually 2 red 41. It doesn't have to be always rational numbers. Okay. Right. Now sometimes you can answer with what decimal numbers. But it doesn't matter, you can use decimal numbers. But in this case, we have to use our calculator. All right? So now let's do this one anyway. This side, you're gonna learn this one. X, this side is X. But X is one of the leg. Now we apply Pythagorean theorem because this is a right triangle. X squared plus 8 squared equals 17 squared. Oh, we already know that, right? 8, 15, 17. X is 15. We know the right triangle privilege with what 8, 17. The other numbers should be 15. But we're going to solve this one using Pythagorean theorem anyway. So x squared equals how much? 8 squared is 64. 17 squared is 289 minus 64 and minus 64. X squared equals 289 minus 64 is 225. What is the value of x? Square root again. X equals how much? 225 actually equals what? 15 times 15. 2 numbers already. Now out. 15. Square root 1, nothing left. Just 15 is the answer, right?
I'm just a little confused how we just got 15.
Okay. 225. Square root 225 is what? Square root 15 times 15. By definition, if we have the same number over here, it's going to be equal 15. 15 square root 15 times square root 15 equals 15. Our definition, isn't it? Square root 8 times square root 8 is what? 8. That is our definition.
Oh, I see. So
yeah, memorize, okay? Because we define this way, okay?
So 225 equals 15.
That's right. This was actually 15 times 15, right?
Yeah.
Okay, so we have 2 numbers. Actually, this is separate this way. Square root 15 times square root 15. That is a square root 15.
Okay, I got it.
Got it. Thank you. All right, this is also what? X over here. Same thing. 14 squared plus x squared equals 20 squared. That is the Pythagorean theorem. This is 196. 14 squared. You can use your calculator, okay? 14 squared is 196. And plus x squared equals to 20 squared is 400. Now, minus 196 minus 196, x squared equals how much? Okay, we're going to use our calculator. Okay, just give me a moment. Can you see the calculator there? All right, this is the calculator. 400 minus 196 equals 204. X squared is 204. X is what is that? I'm going to write that. X equals square root 204. 204. But we're gonna check. Inside 204 have some perfect square numbers. Okay, divided by 4 first. 4 times 104 divided by 4 is what? 51, isn't it? This is square number 51 is what? 3 times 17, no more perfect square numbers. But this number 4 square numbers move out to red 51, okay? Or you can use it in decimal place, just what? 2 times square root over here. Can you see that? Square root 51. You can get a decimal number. Approximately what? Nearly tens is what? 14.3, right? All right. Now everybody has some question, okay, practice. Okay, you can use, okay, your calculator or just the exact number is okay too. Okay, everybody try this one. We're gonna find the diagonal. Diagonal, this is diagonal. Kind of what? Hypotenuse, right? This is diagonal. Okay, now let's find diagonal first. Exercise 5. Everybody try exercise 5. You can use this diagonal x, this also x. This is x squared equals 5 squared is 25 plus another 5 squared is 25. So actually x squared equals 50, right? It's okay. Now x is square root. X equals how much? Square root 50 by definitions. Now let's find. Inspect. Do they have any perfect square number? Yeah, 25. Because 50 is what? 25 times 2 is 50. This 25 is the perfect square. What is that? 5 times 5. But this number 5 is what? Out. Right? Square root 5 times square root 5 is just 5. This is what? 5 red. Are you guys with me? Okay, another one, second one. We try again. 7 squared. I'm going to write down, okay? 7 and 3 first. 7 squared plus 3 squared, that is equals x squared. We just set up the right equation using Pythagorean theorem. Okay, 7 squared is 49. 3 squared is 9. That is x squared. From here, x squared equals how much? 9 plus 58 is what? 49 is 58. Now, how can you find the value of x? We make a square root, right? We did already. So x equals square root 58. That's the answer. But check it out. When you divide it by 2, 58 divided by 2 is 29. There is no more perfect square number. This is prime number. This is only one number. Okay, so we cannot simplify. Just what x equals square root 58 is the answer. Okay. Okay, now we're gonna work together. Number 1, because today's okay, I'm not gonna give you your homework because our last day. Okay, so we just try the homework together. All right, number 1, we have right triangles, so definitely we can use Pythagorean theorem. Yeah, we have legs A and B. Okay, which equation below is already true? Anybody give me the answer? Number 1.
Number 3.
Yeah, that's it, right? Because what? A squared plus B squared is C squared, because that is on right triangle. That is already true. All right, number 2. For which of the following find the length of missing hypotenuse using the Pythagorean theorem? When answers are irrational, round, and near, and just leave the right, correct, and you have to write down. All right. Now let's find this hypotenuse. They are all, I'm gonna write this as hypotenuse x, x, x. Try number 8. Set up the equation, Pythagorean theorem, right? 4 squared plus 3 squared, that is x squared. We know that 3, 4, this is 5. We already know that 3 to the 4 to the 5. But I'm going to find that this number 5 using Pythagorean theorem, okay? 4 squared is 16. 3 squared is 9. That is 25. This is equals to what? X squared, isn't it? All right, how can you find x? Square root, square root. Square root x is what? Just what? Square root x times another square root x is x, right? X equals square root 25 is what is there? 5 times 5, right? Two equal number there, which is 5, isn't it? So this side is 5.
That actually makes sense. You could find
Yeah, that is true.
Make it equal.
Yeah, that's true. All right, number B. What is the value of x? Try this one. Everybody try this one, okay? If you got the answer, you let me know, okay? Okay, I just got right the value of x, which is 17, okay? X squared equals 8 squared plus 15 squared. 8 squared is 64 and 15 squared is 225. Some of these numbers is 289. So that is the value of x squared. When you make a square root over here, square root 289 is 17 times 17, okay? That's why I suggest I memorize 289 is what 17 squared. So which is 17? That's the answer. All right, number 14. 11 squared, 14 squared equals to x squared. Because what at the beginning I told you to memorize these perfect square numbers. Now can you find the reason why I asked you to memorize this one? Something like these questions. 11 squared is 121, right? 14 squared, you know they're 196. When you add these numbers, how much? Okay, you can use the calculator. 121 plus 196, 317. This is 317. That is equals to x squared. But 317, can you break these numbers? $319. Okay, in this case, you're gonna use, okay, calculator. X equals, what is that? Square root, that is x. Square root, we still don't know. Check it out. Square root 319. Square root, use the calculator, okay? 319 equals 17.86 because this is not perfect squared. Is it okay? So in this case, you can use what decimal. X equals approximate what? 17.9, nearest the tenth. Okay? Okay, this one is 3 squared plus 3, another leg 3 squared equals x squared. 3 squared is 9, another 3 squared is 9, total is what? 18, that is x squared. Right, so we can make a square root over here. X equal how much? Square root 18. You can use a calculator, but this is very simple. I'm gonna find the exact number, okay? 18 over here, actually what? 3 times 2 is 18. You can see over here 2 numbers equals 9 is the perfect square numbers. So square root 3 times square root 3 is 3. So actually this one equals 3 is out, 3 record, 2 is the length of this side. Okay. A little more. Now you can use, okay, calculator from now on. Okay, this side is that. So we're gonna work to get the number 8, or the other one is yours. Okay, 16 square plus x square equals hypotenuse square, 20 squared. 16 squared, we know that 256, and plus x squared equals to 20 squared is 400. So x squared equals what? Minus 256, minus 256, 144, right? So square root over here, x equals what? Square root 144. But this is 12 squared, we know that, okay? Also, you can use a calculator. Square root 144. Can you say that is a square 12? Yeah, that's the 12. This one of the lengths is now 12, okay? Okay, everyone try B and C and D, okay? Once you find this, you let me know, okay? Okay, go ahead. Okay, Victoria, can you try number B? What's the equation? I'm going to take this as X.
25 squared. No. Is it
Okay, take time. 하자고 set up the equation first.
So it's x squared
X squared plus
a squared.
X for 10 square, right?
Oh, 10 squared equals 25 squared.
That's right. Now we need to find the value of X, okay? X squared, 10 square is 100. 25 square, or you can use 25 square. You can use your calculator, okay? 25 times 25, 25 square is 625. So x squared equals how much? Minus 100. Minus 100 is gonna be square root 5 to 5 when you make a square root, okay? From here, x equals square root 5 to 5. They want to use that calculator, okay? So we have square root 5 to 5. How much? Around what? 22.9, okay? 22.9. That's this, okay? Okay, now finish what C and D by yourself, okay? Okay, everybody try this one. We're gonna find the missing side. This is X missing. This side is now missing side. Are you guys okay? Anybody had the answer key? Answer number C. All right, set up the equation anyway. Leg square plus another leg square. This is a leg now, not hypotenuse. This leg square plus another leg n squared, that is equals to square of this one, 12 square, right? Because we already know that. Area of this one plus area of this one equals area of this one. That is Pythagorean, right? So this here is x squared, x times x. This here is 10 times 10. This is 12 times 12. That is okay? All right. So now let's solve it. X squared, 10 squared is 100. 12 squared is 144. And minus 100, minus 100. X squared equals how much? 44. Now, how can you find the x? By definition, square root, square root. Now, this x squared square root is x equals, now you can use it, right? Square root 44 equals how much? 6.6 is the answer. And you should over here, if you got the same number, square root 10 times square root 10. If you got the same number, always equals to 10. Okay? That is with our definition. We define this way. Or in the same square root 10 times 10, same number. You don't have to always separate right this way. It's the same thing. Square root 10 times square root 10, same thing. But inside, okay, square root 10 times 10 still equals 10. Is it okay? We define this way. We need to follow the right our definition. Okay, another one over here, 24 squared. And one of the leg is still x squared equals to a hypotenuse square, right? 26 squared. So x squared, 24 squared, I'm gonna find the 24 squared is how much? Everyone know this one? Okay, 24 times 24 is how much? 576? Yes, 576. I told you memorize. That's right? No? Up to 30? No, I told you remember up to 20, right? Okay, this is fine. X squared equal to 26 squared, how much? 26 times 26, how much will be around the, anyone know this one? 676. So minus 576, minus 576. Wow, this is exactly equals to 100. Simple. But this version, you don't need the right calculator. Just what? X equals square root, we know that square root 100 is square root 10 times 10, right? Same number, this is 10. That's the answer. Okay, sometimes we might be irrational number, okay? But in this case, we need to use your calculator. All right, now let's do this way anyway. We're gonna find the length of this hypotenuse. This is what the leg. You can use this one, 24 squared plus another leg of 49. Square. Same form, okay? 7 squared. That is equals to 8 squared. No, 8 squared. Now from now I'm gonna use the calculator. 24 squared, 24, this is recess squared. Or you can use a 24 on your calculator, that's just squared. And plus 7 squared, it's okay? That is equals to 625. Now we need to make a square root over here, right? But this is what x, isn't it? Square root 625. How much? Square root 625. 25. How much is around? 25, we already know that. All right, number B, still we set up the equations. X squared plus A squared is 64 equals 14 squared is 196. I just skipped one step. Minus 64 minus 64, X equals how much? Minus 64 minus 64. 132, right? Okay, to find X, you can use what square root? X equals square root 132. Use calculator. Square root 132. That is not perfect square number. It's going to be 11.5 nearest tens, okay? That's this. This is not hard, right? Okay, this is go over section again. A squared plus B squared equals C squared is called Pythagorean theorem, okay? No, I'm gonna skip this one. Now check. Now the next question is, we have three sides. If this side forms what, right triangle? How do we check this one? It satisfies the Pythagorean theorem, that is the right triangle. If not, that is not the right triangle. How can you check it? Use the formula here. C is one longer side, which is C. This is C longer side. All the other two is leg. This is hypotenuse. Okay, so you have to check it. These three sides satisfy the Pythagorean theorem. 2 leg square, 28 square plus 45 square. Ejected this one equals to 53 squared. That's true or not? We can check it out. You guys can see the right calculator, right? Let me see. Yeah, you can see the calculator. 28 squared plus 45 squared. Use a calculator equals 2,809. 53 squared will be 2,809. Check it out. Same numbers. Same numbers. Yeah, this is forms one right triangle. This is 53. This is 28. This is 45. Yeah, that is true. That is right triangle. Okay, all these three sides create right triangle. What about B? Check it out. This is hypotenuse, longer side, 17 square plus 22 square equals 29 squared. We have to check it out. If they are equal, that is a right triangle. If not, not right triangle. Use a calculator, okay? 17 squared, we can use 17 squared. And plus 22 squared. How much this one? 773. What? 29 squared? I don't think so, right? 29 squared is not 773 because the 841 totally different. That is not. So this is not the right triangle. Okay, using these three sides, we cannot create the right triangle. Not the right triangle. Are you guys with me? Okay, now check it out. All these three sides can form the right triangle. All right, this is the longer side will be hypotenuse. The other one is the leg. So 15 square and plus 36 square, that is just equals 39 squared. Check it out. 15 squared plus 36 squared. 15 squared plus 36 squared equals how much? 1521. 39 squared will be 1521. Yeah, very close. Check out 39 squared. This is a work or true or false. How do you think? True. They are equal. So using these three sides, they can, when they are built triangle, that triangle is a right triangle because it satisfies the Pythagorean theorem. Okay, Pythagorean theorem already working only on a right triangle. That's why. Okay. Oh, I told you over here what is Pythagorean triplet. Just a triple is okay. Okay, if all three numbers, okay, all that three numbers satisfy Pythagorean theorem, we can say that numbers are Pythagorean triple or right triangle triple. Triple means three numbers, right? Okay. Now we check it out. Okay, all these numbers are Pythagorean triple or not? How to check? Check it out. All three numbers satisfy Pythagorean theorem. This is hypotenuse longer side. So 3 squared plus 4 squared equals 5 squared. We have to check it out. 4 squared of 9. 3 squared is 9, 4 squared is 16, total is 25. Right hand side, 5 squared 25. Yes, that's true. So this 3, 4, 5, we said Pythagorean triple. Yep. What about B? This is a Pythagorean triple. It can be. Let's check it out. This is hypotenuse, longest side. This is not. Hypotenuse always the longest side, okay? Longest side. So this two leg, this leg, 14 squared plus 22 squared equals 3 squared. They are equals. This one we check it out using your calculator, okay? It doesn't matter. 14 square over here. And plus 22 n square. How much this one? 680. This is really equals to 30 square. 30 square is 900. Totally different, right? So this is not the side of a right triangle. This is not Pythagorean triple. This is not. Yeah, C is a definite triple, right? Pythagorean triple, because we know that 5 square and 12 square exactly equals to 13 squared. 5 squared is 25. 12 squared is 144. And 13 squared is 169. That is true. 25 plus 144 is 169 equals 169. So this three side is called what? Pythagorean triple or right triangle triple. Okay, Pythagorean triple is okay too. Yeah, try just one more, okay? Just one more. I'm gonna try this one, harder one, very biggest number. 32, 47, 57. Yeah, this is a Pythagorean triple. When you use this to decide, can you create a right triangle? Check it out. 32 squared, 47 squared, to be right triangle triple or Pythagorean triple, it should be satisfied this one. You can check it out. Use your calculator. 32 squared, that is 32 squared, and plus 47 squared. This is what? 3,233. Wow, very big number. 57 squared. Is this 32, 33? How to think? I think that is true. I think that is true. Wow, a little different, right? 57 squared is what? 32. 49, very close by anyway, then if I am wrong. Okay? Yeah, these three numbers is not called Pythagorean triple. Okay? Right, if they are equal, yep, then numbers are Pythagorean triple. Okay, the next one is, we already know that 3, 4, 5 is Pythagorean triple. Very familiar with us, right? You memorize this one. When you have a 3, 4, 5, that is Pythagorean triple. But if they increase with same rate, times 2, times 3, times 4, still Pythagorean triple. This one is family group. So times 2 is what? 2, 3 times 2 is 6, 4 times 2 is 8, 5 times 2 is 10. This is also Pythagorean triple. Because what? We know that 3, 4, 5, this group is called what? Pythagorean triple. When you multiply some numbers, always what? Pythagorean triple, we know that. Using this one, we can say, oh, this is what? Pythagorean triple. What about this one? Times 3 over here, right? 3 times 3 is 9, 4 times 3 is 12, 5 times 3 is 15. This is also Pythagorean triple. You don't need to write work. We already know that. This group, which has what, 3, 4, 5, always Pythagorean triples. 3, 4, 45, wow. You want to make a square? Now we know that when you divide by 11, that is what? Kind of a 3, 4, 5, isn't it? Yeah, this is a group on this one. There is a Pythagorean triple. Okay. So this one also you can divide by 3 every side. What is that? 3, 4, 5. This one, Pythagorean triple. This one you can divide by 2, 3, 4, 5. Okay, you can go right backwards, reverse way too. So very popular Pythagorean triple is what? 3, 4, 5. The next one is 5, 12, and 13. The next one is 8, 15, 17. This is a popular what? Pythagorean triple family. When you make 2 times 3 times 4, it's the same group. This also what? Times 2 is what? 10, times 2 is 24, times 2 is 26. This also 5, 12, 13 group, Pythagorean triple. This one times 3, 24, times 3, 45, times 3, 51. When you simplify, you'll get what? 8, 15, 17, right? This is a Pythagorean triple. Memorize all these 3 numbers, 1, 2, and 3. This is a popular Pythagorean triple. In this case, you don't have to work out because we already know that, right? If you don't understand, you have to try Pythagorean theorem. This one is triple, this is working. 9 squared plus 12 squared equals 15 squared. This is the way you can find they are Pythagorean triple or not. Okay, but sometimes if you remember these basic groups, using this basic group, you can make conclusion up here, right? Because this is belongs to a 3, 4, 5 groups. Are you guys with me? All right. Now we have 2 boards over here, 8 and 12. So we're gonna put that over here, diagonal from here to, we're gonna find what the length is one. Oh, we don't have right, any board. We don't have any, right? Long board over here. But using these 2, you can make, right? You can measure this one. Right, to measure from here, why it's very hard to measure this line. Dangerous. So using these 2 sides, we can measure this side. How? Pythagorean theorem. 8, 12, isn't it? So you know that x squared equals 8 squared plus 12 squared. 8 squared is 64. 12 squared is 144. Total is what? 208, right? But you can use a calculator. Square root 208. Around 14.4. So x squared is this one, square root, x equals, what is that? Around 14.4. You can get the number using Pythagorean theorem. Okay. So many times we use this Pythagorean theorem for the what? We cannot really direct measure with this one. For example, this is very big horse. Lake, or very long. You're gonna find that the length with this side long. Wow. You're gonna go into the water? No, that is so dangerous. The water is so deep. You cannot measure from A to B. That is impossible. You wanna swim? It's gonna be around what, 10 kilometers or 2 kilometers. Wow, that's just so long, impossible. Now, if we use the Pythagorean, you can measure over this one without swimming, right? You can make some length of this is what the water, but this is the earth. You can make some earth over here. But make some line over here perpendicular, right? Approximately perpendicular. You can measure this one because this one is what? Earth. Ground, right? This is the water. This is land. You can measure. You can measure this one too. This is A and B. But this is a kind of what? Hypotenuse, right? So square root, what is that? A squared plus B squared, isn't it? That's why Pythagorean is very useful, right? For measuring sometimes what the people cannot measure, okay? All right, now we're gonna have 10 minutes break. We'll continue some practice on Pythagorean theorem, okay? Right now, 2:03, 2:13 p.m., okay? Everybody come back here 2:13, okay? All right, 10 minutes break. Okay. All right, okay, back to work. All right. Just try one of two questions. Okay, one or two, that's enough, I think. All right, determine if each set of lengths below could be the length of a right triangle. Okay, yes or no? So how can you check out if they're satisfied Pythagorean theorem, that is length of right triangle? Okay, if not, they're not length of right triangle. That means what the triangle is not right triangle. I'm gonna try this one too. Okay. Take a look over here. 12 square, 18 square is that equals to 30 square. Is it true or false? Just check it out. 12 square, you can use a calculator, okay? But in this case, you can use a calculator over here. 12 square over here. 12 square if you have a square there, and plus 18 square over here. That is equals to 468. But 30 square is 900. Right? They're not equals. This is not right triangles? No. What about E? This is the longer side, which is the hypotenuse. So 33 square plus 56 square, that is equals to 65 square. You check it out. 33 squared and plus 56 squared equals how much? 4,225. Right, this is 65 squared. Yeah, that's same numbers. Yeah, this is the side of a right triangle because now we say these three numbers are Pythagorean triple. Okay, that's the way, okay? All right, that's the homework. I'm gonna jump, okay? Okay, we did this one, right? We already know that 3, 4, 5 is what Pythagorean triplet, okay? Yeah, this one is the side. This also what Pythagorean triple. What about this one? You can divide by 4, 3 to the what? 4 to the what? 5, isn't it? You can divide it by 4. This also what belongs to here, okay? Pythagorean triple. But this is not. 7, 24, 27 is not Pythagorean triples. So these three sides cannot be the side of a right triangle. Okay, you can check it out. 7 square plus 24 square equals 27 square. Is it true or false? Use a calculator. 7 square. Oh, yeah, to record it, right? 7 squared plus 24 squared equals 625. 27 squared is not 625, right? You know that 729, they are totally different numbers. So this is not the side of a right triangle. Okay. So number 3, which of the following isn't Pythagorean triples? When you divide by 2, this is a 5, 12, 13, same group. This is triangle, right triangle triplet, okay? You can divide by 10, it's what, 5, 12, 13, same groups. Also, this is a Pythagorean triple. When you divide by 3 over here, this is a 5, 12, 13, same group, but this is not. Okay, it can be a right Pythagorean triple. You can check it out anyway. 10 square plus 17 square, is that equals to 18 squared? That is true or false? Use your calculator. 10 squared plus 17 squared equals 389. You know the 18 squared is not 300, right? The 18 squared is what, 324, right? They're not equals. So this is not the side of a right triangle. Okay, you can apply any the Pythagorean theorem for anything to find the right diagonal, kind of diagonals. Okay, now we're gonna find out A to B, the length of this side. Yes, this side, the AB square equals, what is that? 10 squared, Pythagorean theorem, 10 squared plus the other square is what, 6 squared. That must be equal, right? This is 100 and plus 36, 136. So when you make a square root, from here we can say AB equals what? Square root 136, okay? Now let's find square root 136, approximate right there, 11.7 feet is the answer, okay? Number 5 is the same thing, the ramp over here. But we're gonna find out how high did this one. Okay, any missing number will be the x. But this time 20 is the hypotenuse, okay? So x squared, leg squared for another leg is what? 18 squared. That is equals to what? 20 squared, isn't it? That's the Pythagorean identity theorem. So x squared and equals how much? 20 squared is 400. 18 squared is 324. Total is how much? 76. It's okay? So what is the value of x? X equals what? Square root 76, isn't it? Okay. Square root 76 equals 8.71 is the length of this side. Okay. This is the same thing. I'm not going to do this one, okay? All right, same thing. Just to go over. Just what? Application over here. Okay, we use this formula to find the special right diagonal, right? This is a kind of a diagonal, isn't it? Diagonal. All right. This is okay. Now, special, we're going to try this one. How we apply this Pythagorean theorem using in real system. In real, looks like this way. A car starts by driving north 5. This is right, north, south, east, and west. To going to north 5 miles. And then drives what? To east, 12 miles. The car is over here. Draw a diagram by this scenario and determine the straight line. Where is the straight line? This is a straight line over here. We're gonna find this length. North, east, what they are perpendicular. This is the right triangle. How can you find this one? Diagonal, we already know that, right? This is what? Pythagorean triple, 5, 12, 13. This length will be 13 miles, okay? That's why I want to ask, right, Pythagorean triple or right triangle triple, okay? You guys know what is isosceles triangle? Isosceles triangle is the two sides are equals. This is also what the name of these two sides also a leg. This is now, we said base. We don't say hypotenuse, okay? This is the base. So these two legs are equal, right? For the isosceles triangle. Now, especially on this right triangle, we're gonna find the area. Wow, how can you find the area? Because this is not right angle. So in right isosceles triangle, this is, we said vertex. From the vertex, we make right the line perpendicular to the base. This is the height. By this case, this perpendicular lines always bisect at the base. Each side is 6, 6 and 6. Now to find the area of this one, we got the base over here 12, we need the height. We need to find what the height using what? Pythagorean theorem. 6 squared plus height is h squared. That is equals to 10 squared, right? You already know that 6, 8, 10, 3, 4, 5, it was 6, 8, 10. This longest and one of the legs 6, the other one is 8. We know that 6, 8, 10. Or you can solve this one, right? 36 plus h squared is 100. H squared is what? Minus 36. Minus 36 is 64. The square root h equals 8. This is 8. Now what is the area of this isosceles? What is the area of this isosceles? Base is now still 12. Height is 8. and divided by 2 is the area of this original isosceles. Okay, when you divide by 2, this is 1, this is 6. So area will be 48 is the area of this isosceles triangle. Is it okay? Now you're gonna find this hypotenuse. You know that, right? How to find this one. Now, we have a right trapezoid. What is this right trapezoid? One side over here, one of the leg, always perpendicular, right? This we said I saw a right trapezoid. Regular trapezoid looks like this way. There's no perpendicular lines there. This is regular trapezoid. This side is also the name of this one still leg and leg. But one of the leg is a perpendicular. In this case, we said a right trapezoid. How can you find this side? This is the missing side. All 3 sides are given. 10, 15, 12. How can you decide? This is we say the slant side, which is a slope. This will make it the line over here, perpendicular. This is 12. Total is up to here 15. This is 10. This is 5, right? Now these are how much? 5, 12, 13. Because we already know that Pythagorean triple, 5, 12, 13. We don't need work, okay? Just try to use Pythagorean triple, 5, 12, 13. 3, 4, 5. 5, 12, 13. The other one, 8, 15, 17, okay? Now we're gonna have some practice how we find the area of isosceles. Tackle this one. This isosceles equal, when you make a draw over here, that is a bisect opposite side, each side is 8. Now still we need what height to find the right area. How can you find height? Apply Pythagorean theorem. But we know that Pythagorean theorem triplet the 5, 15, 17. 17 is the longer side, which is hypotenuse. One of the leg of 8, the other leg should be 15. We don't need work. We already use what Pythagorean triplet. Now how can you find the area of this one? Base still 16 times height is 15 and divided by 2 is the area of this isosceles. 16 over 2 is 8. We know that. 8 times 120 is what? 8 times 15 is 120. Is the area of this isosceles. Now tackle this one. This is also isosceles. This is the height, which is about 4, 4, right? But this is not Pythagorean triple. Actually, we need to find the value of h. 4 squared plus h squared equals to 12 squared. 16 plus h squared equals 144. And h squared is 144 minus 16, right? Okay, 144 minus 16 is how much? 128. So h the square root, 128. How much is this one? You can use this one later, okay? So area equals to base times, base is what still 8 times height is what square root 128 and divided by 2, right? That's the area of this isosceles triangles. Divided by 2, this is 1, this is 4. Actually, 4 red, 128. 4 times square root 128. That gives us the same number, 45 and 0.3, nearly the tenths. Okay, square centimeter is the area of this isosceles. All right, now move on this one, okay? Now, everybody try this one, number 3. I'll give you some minute. This is just a regular one. Trapezoid, but these two sides is equal. What that means? The name of this one is isosceles trapezoid. This we said isosceles trapezoid. Okay, these two sides is equal already. To find the area with this trapezoid, we know that base 1 times base 2, upper base times the bottom base, and times the height and divided by 2 is the area of this trapezoid. But still, B1, B2, where is height? This is the height? No, this is the height. You're gonna find the value of H. We know that B1 is what, 15, B2 is 25, height is we don't know, and divided by 2, right? We need to find this value of H, which is the height of that trapezoid. How can you find height? Yep, you can use Pythagorean theorem. 15, 15. This is 15. So these two triangles is what? Equal triangle. These two sides is equal. 25 minus 15 is how much? 15 is what? 10, right? Sum of these two sides is 10, but they are equal, half and half. This side is 5, the other side is 5, 2. Now I can see this is 5, 12, 13, triangle triple, or Pythagorean triple. 5, 12, 13. So height should be 12, isn't it? Now we just got right H to 12 using Pythagorean triple. This is now 13. 15 plus 25 and times 13, no, 12, right? 12 over 2 is the area of that trapezoid. 15 times 20 is about 40. This one you can divide by 2. This is 6. So 40 times 6 is what? 240 square inches area of that trapezoid. Are you guys with me?
Yeah.
I believe so, okay. You can do that, this one. There are more on, I'm gonna try only 2, okay? That's enough, I think. They are all what Pythagorean theorem to find the diagonal. All right, number 4. But they're not asking you diagonal. This is one of the leg, but still Pythagorean theorem. 4 square, leg square, and the other leg is what? H is leg. H squared, that is equals to 10 squared. That is the Pythagorean theorem. 4 squared is 16. Okay, step by step, H squared equals 100. 10 squared is 100. Subtract negative 16. Negative 16 there. Now we got what? H squared is square root. Just 84. But in this case, what is that? Square root, right? Square root. H equals how much? Square root 84 is the answer, okay? But nearest answer using calculator. Square root 84 will be around 9.2 around, okay? This would be 9.2. Don't forget, okay, to write the unit bit. That's the length of this H. All right, one more, number 5. All the other are just same thing, okay? Wow, this is the same thing. I'm not going to do this one. Maybe number 6. All right, what is that? Or 90 feet. Okay, this is from second base to home base. This is home base, second base. This is what kind of what? Diagonal, right? This is right angle. And what this is what? X. Which is right? Hypotenuse. Okay, this is a leg, another leg, which is a right angle, right? So 90 squared plus another 90 squared, that is equals to what? X squared. 90 squared is 8100. I'm going to use calculator, okay? 90 squared plus another 90 squared equals how much? 16200. That is square of x. Okay? That's x squared. What is x? X equals how much? Square root, okay? Square root 16200. That is the value of x. Square root 16200. 127.3, right? Fit. It's okay? Oh, someone send me. Oh yeah, okay. Okay, during the class, you can go right back to any time, okay? That's it. All right, yeah. This is now, using this Pythagorean theorem, how we find the length of what? Between 2 points on geometry. These are final topics, okay? That is our final topics. Because after this, if we finish this one, we almost want 90% covered, 90% of pre-algebra covered, okay? Only two, scientific notation and probability. Scientific notation is very simple, probability is nothing, okay? All right, now how we use Pythagorean theorem, okay, to find what? Length between 2 points. Take a look. We're gonna find over here. Point A is over here. When x equals 0, y is 6. That's the right point A. Now what is the coordinate of point B? 8, 0, right? This is 8, 0 coordinate point B. How can you find the length of this one? You can use Pythagorean. So what is the length this side? What is the length this side? 6, isn't it? What is the length of this side? You make a right triangle between these 2 points. Okay? One of the leg is what? Vertical leg is 6, horizontal leg is 8. What is the hypotenuse? 3, 4, 5, 6, 8, 10 group. This one is 10. 6 squared and plus 8 squared equals AB squared, isn't it? We know that 6 squared is 36, 8 squared is 64. It's gonna have 100. That is equal to AB squared. Maybe you can make a square root. AB equals 10, isn't it? Square root 100 is what? 10 times 10, that is 10. Or you can use the right Pythagorean triple. You know that, the numbers. Okay, so between 2 points, that's why we can find this one. How can you find this one? B. This is what it is. Y2 minus Y1, right? Because this is a zero up here. That's why we said Y2 minus Y1. That is like this one. What is this one? X2 minus X1. This is what? X2 minus X1. Okay? This side is what? X2 minus X1. 8 minus 0. This side is what? The value of Y. 6 minus 0. It's okay? So we find a very important formula by using this one. The distance square equals how much? X2 minus X1 squared. X2 minus X1 squared. And plus Y2 minus Y1 squared. But this is squared, except this one, we make a square root. That's what distance formula. This is we set distance formula. Distance formula exactly equals to what? Pythagorean theorem. Same thing. Okay, this is the same thing. This one square part, this one square, right? So now we're gonna have some practice over here. We have a point 3 and 2. And this is 3 and 2. This is the point A. Point B is 9 and 6. X is 9, Y is 6. That is the point B is 9, 6. Now we're gonna find the length of this side. On the graph, we can make a right triangle. Make a right triangle. But this side is how much? This is 3. This is 9. Actually, 9 minus 3, right? X2 minus this is what? 3 and 2. 9 minus 6 is 6. This is 6. What about this side? 6 minus 2, 1, 2, 3, 4, right? 6 minus 4, 4. Now we have two legs already, 4 and 6. This one is now I'm going to use the directory AB equals what? Square root, right? Directory square root 6 squared and plus 4 squared. Is it okay? So simplify 6 squared is 36, 4 squared is what? 16, which is what? Square root 52, right? Okay, make a round. Square root 52. How much? Around what? 7.2, right? That's the way you can find the length of this between 2 points. Is it okay? We just did it, right? We plot 2 points. We make right hypotenuse over here. And we use the Pythagorean theorem, okay? Now, we're gonna try this exercise 4. All right, we have a 2 point, 4 and, okay, let's do this first. This is already 2 point, right? There's no graph, but this is actually, right? 3.2, this is at 9 and 6. That is the coordinate. How can you find the horizontal length? This is horizontal length. How can you find? This is x2 minus x1, right? 9 minus 3 is 6, isn't it? So 9 minus 6. That is the horizontal length. Where is the vertical length? 6 minus 2. That is 4, isn't it? 6 minus 2 equals 4. That is what? Vertical length. Okay, that's it. Now we have a 4, 9, 9, 6. We know that horizontal is by x2 minus x1 is horizontal, right? 9 minus 4 is how much? 5. What is the vertical? Vertical is what? Y2 minus y1. 15 minus 3. 15 minus 3 is 12. That is the vertical length. Okay, so we have this one. Horizontal is 5. Vertical length is 12. This is right angle. We know that. What is this side? 5, 12, 13. Isn't it? Pythagorean triple. 5, 12, 13. Do you remember? 3, 4, 5, 5, 12, 13, 8, 15, 17. Now we're going to use the formula over here, okay? Okay, one more time. Distance now, you can use, right? Horizontal length is what is that? X2 minus X1 squared. And the vertical length is what is that? Y2 minus Y1 squared. When you square over, it's positive, right? Okay. You can use this one is X2, Y2. This is X1, Y1. Now, X2 minus X1. Square root. X2 is 6, X1 is minus 2. So what is that? 6 minus 2 squared. And Y2, negative 5 minus 10 squared. That's it. 16 minus 2 is what? Positive 2, 18 squared, right? The first one is horizontal length will be 18 squared. Vertical square is what? Negative 15 square, right? Negative 15 square is positive 15 square, same things. So when you calculate this one, 18 squared plus negative 15 squared, it's a positive one anyway, equals how much? 549. Okay, so you can make a square root 549. That is equals what? Around 23.4 is the distance between the point. Is it okay? Now use the formula one more time. This is the formula. But in this case, just find out that difference too. You don't have to solve what x2 minus x1, just what difference. I'm going to use a little different way. Horizontal difference, 7 and negative 5, how much? 7 minus 5, 12, isn't it? That is horizontal difference. What is the vertical difference? 2 and 11. 11 minus 2 is what? 9 squared. You can use this way too, it doesn't matter. Or you can use what the formula. Formula is what? The x2 minus x1. x2 minus x1, right? So negative 5 minus 7 squared. Negative 12 squared is positive 12 squared, okay? The next one, y2, 11 minus 2. That is what? Is that 9 squared, right? It's the same thing. So square root 12 squared is 144, and the 9 squared is 81, total is what? 225. 225 square root is what? 15, isn't it? Is it okay? All right, almost done. That is one more. Now we're gonna have some practice. Okay, everybody try this one, number 1. Go ahead. Everybody try this number 1, okay? If anyone got answer, please let me know, okay? We have a point 0, this point. At this point, 9 and 0. What is the length of this side? AB, okay? Find out. Give me your answer, okay? From the graph, you can find the length of AB, right? Because we already got graph over there. Make a right triangle. This side is 9. The other side is its length, 7. Okay. So AB equals to square root. Okay. 7 squared or 9 squared. And plus 7 squared. That's the answer, okay? 9 squared is 81. 7 squared is 49. That is equals to what? Square root 130, right? That's the answer. Is it okay? Pythagorean theorem, c squared equals to a squared plus b squared, right? Or you can use this c equals what is that? Square root a squared plus b squared. It's the same thing. All right, number 2. We have 2 point 1 and 2, still graph. You can use the graph over here. This is a right triangle. This length is how much? 6 minus 1, right? Because this is 6, 8. This point 1 and 2. x2 minus x1, 5, right? 1, 2, 3, 4, 5. This side is 5. This side, how much? 8 minus 2 is 6. We already got two numbers. Now, from the graph, you can measure horizontal length and the vertical length, right? So, hypotenuse, this is C. C equals how much? Square root 5 square and plus 6 square, 36. That is the length of what? C, okay? So you can use the formula over here, square root 25 plus 36. That's it. 7.8 is the answer. All right. Now we're gonna plot these 2 points to find the length. -3 and 4. Where is -3 and 4? M is already there. And is 9 and -1. 9 and they already got over here. We're gonna find the length this side. But make right triangle. That's it. You can measure about 1, 2, 3, 4, 5. This side is 5. This side is how much? You can count it over 9 minus 3 is what? 12, right? This is 9 and minus 12, that is 12. This is 5, 12, this side will be 13, right? Pythagorean triple. All right, move to the next one. Okay, how can you find using the formula, all right? Using the formula, horizontal is what? 6 minus 4, but just we need what distance, that's why we prove here absolute value. 6 minus 4, 10, the length, horizontal length is what? Between these 2 points is 10. Vertical length, 8 minus 4 or 4 minus 8, doesn't matter. 4 minus 8 distance is 4. This is the vertical length, this is the horizontal length. Okay, using Pythagorean theorem, you can use what directly. C equals to how much? Vertical length, horizontal length, plus vertical length. That's it. Okay. Now we're going to try number B over here, right? What is the horizontal length? 11 minus 3 or 3 minus 11, it doesn't matter. Just what? Big one minus small is better. 11 minus, we don't need the absolute value anymore. 8. That is what? The length of horizontal. Okay, all right. Now vertical length. B equals how much? Which is big? This is big. 8 minus 2 is 6. That is the vertical length. Now apply Pythagorean theorem. Diagonals, how much? Distance is how much? Horizontal squared and vertical squared, right? This is what 64 and plus 36 equals what? Square root 100. Now square root 100 is what? Square root 10 times square root 10, right? Which is 10. That's the answer. Is it okay? Just find out vertical length and horizontal length. Try C again. What is horizontal length? Big one minus small one is better. 4 minus 4. That is difference 8. Vertical length, this is big. 12 minus 3. 12 minus 3. Vertical length will be 15. Okay, now distance, how much? Square root. Horizontal length is 8 square. Vertical length is 15 square. We know that 8, 15. The third one is what? If this is 8, this is 15. What is this size? 17, right? Because this is what? Pythagorean triple. We already know that 8, 15, 17. Yeah, this also you can calculate. 8 squared is 64. 15 squared is what? 225. Total is 29, right? 29 is 17 squared. So 17 is the answer. Okay, now the next one, the horizontal distance is how much? 10 minus 3 is horizontal, right? X2 minus X1. 10 minus 3, that is horizontal distance. What is the vertical distance? 15, big one minus small one, right? 15 minus 8 equals what? Still 7, isn't it? So distance, Pythagorean theorem. And this is 7, this is 7, right? 7 squared plus 7 squared. That is how much? 7 squared is 49, another 49, 98, square root 98. Use, okay, calculate. Square root 98. How much? Around 9.9, okay? It's gonna be 9.9. We're almost done. All right, we have a 3 point, and -3 and -4. -3 and -4 over here. That is point A. B is just 6 and -4. Okay, where is just 6 and -4 over here? And C is where just 6 and 8. 6 and 8. This is C, 6 and 8. Now we're gonna find the what? Perimeter. Wow. Perimeter. We're gonna find the perimeter. Oh, this line is a parallel, horizontal. This is vertical. It's okay. This horizontal and parallel, we can find it. AB equals how much? AB equals how much? B minus B1, right? 6 minus -3, right? That is 9, okay? 6 minus -3, that is equals 9. You can count over here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now vertical distance, how much? This one. From here, vertical distance 8 minus -4. 8 vertical distance is BC equals what is that? 8 minus -4, which is equal to 12, right? You can count over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's true. This is 12. This is 9. Now we need to find what? AC, isn't it? You have right. This is 9. This is 12. What is this one? You can divide it by 3. This is what? 3, 4, isn't it? This is the 5, which is 15. Or you can use right Pythagorean theorem. 9 squared plus 12 squared. 9 squared is 81. 12 squared is 144. Total is what? Square root 225 equals what? 15. And this side is 15. So what is the perimeter of the triangle? 9 plus, 12 plus, and 15. That's the perimeter of the triangles. Okay, which is what? 36. 9 plus 12, 12 is what? 21 plus 15 is 36. Okay, we are all done this Pythagorean theorem, okay? Any questions about this? Okay, today's our last day, okay? I want to thank you because you guys really work so hard. I understand, okay? So you still have some more weeks for your rest of your summer, okay? I hope you have a great summer, okay? So if you have a chance, we'll see you again, okay? Thanks for joining our class. I'll see you. Okay.
Dr. Chung.
Yep, go ahead.
So I was told that from my parents told me that I wasn't sure when class would end though. I don't know.
Yeah, today's our last class.
Oh, okay. So
Okay.
do they have it during school year or is it just?
Oh yeah, up to what summer when you start, okay, September at the I think in the beginning of September our fourth semester will start again.
Oh, okay.
But in fourth semester, okay, usually, okay, the student maybe the student can ask why the school work, okay.
Okay.
Okay, go ahead.
I think my parent will email you.
Okay.
Or something like that.
Sure. Yeah. Okay. No problem. Okay. All right.
Okay.
Okay. Now let's finish.
See you next week. Are we going to see you next week?
Oh, no, today is our last class.
Oh, okay.
Okay, so rest of the summer, okay, no class. When you start your September, your school semester, our school will start and maybe around September 10th. Okay? All right.
So we're going to see you at September 10th?
Yeah, we'll send out our schedule in fourth semester schedule, okay? We'll let you know, okay, when we start, okay?
Bye.
All right, thank you so much, everybody, okay?
Will
Have a
there be
good-
homework?
No homework will be today,
Okay.
okay? We just finished all homework together, right? Can you see that over here? Yeah, this one is the homework, okay? All right. Okay, thank you, everybody. I'll see you next time, okay?
Thank you.
Okay,
Bye.
bye. Bye, everybody.